being able to do an alligation is a pretty straightforward. Once the light bulb comes on, you can do these calculations. So bear with me. I think you guys can get down this alligation alternative method. It's a different way, but if you stick with me a little bit and give me a little bit of brain cycles, I know you can figure it out. We're going to be doing two things, so don't get confused though. There's an alligation medial that we're going to talk about, which is a weighted average. And I know we'll just do these things to make sense, but an alligation medial is a different kind of math problem where you use this weighted average. Don't get that confused with the one we're really going to focus on, which is this alligation alternative, which is all about proportions. And again, this is what makes everyone happy. Those proportions are going to make these questions much more simple to answer than even doing some of the algebra. Although some of you who are great with algebra can do those, the alligation alternative is a much more straightforward way to do that. But let's start with the alligation medial as an example. So this first question is going to say that a pharmacist mixes 200 grams of a 10% weight per weight ichthymol ointment along with 450 grams of a 5% ichthymol ointment, and 1,000 grams of just a petrolatum base that doesn't have any ichthymol in it, okay? And I just couldn't let that go. That is a picture of a tube of ichthymol. It looks like it sounds. It's gross. It's black, smelly stuff. It's called black drawing salve, and it actually does do a pretty good job of drawing fluid, splinters, things out of the skin, but it smells terribly nasty. Having said that, what we want to do is if we mix all of those different weights of all of those different concentrations, what do we get in the end? And again, we're going to use the alligation medial, which has this kind of three-step method which uses this kind of weighted average. So the first step in the alligation medial is to simply determine the total weight of everything. If you add everything together, what is the total weight of the product? Not of the drug, but of just the total product. So we said we're going to mix 200 grams. And of the 10%, and we're going to mix that with 450 grams of the 5%, and mix that to 1,000 grams of essentially the base that has 0%. So it doesn't matter how much drug is in it, what is the total weight of everything? So you take 200 plus 450 plus 1,000, the total weight of everything is 1,650 grams. Total weight, okay? Step one. Step two is then to say, well, now I just need the total weight of the drug. I don't care about everything. I just want the drug. How much drug is in that product? And to do that, you have to do one ingredient at a time. So if we just start with our 10%, we said we had 200 grams. So we start with our 200 grams, and we said 10%, which is 10 grams of ichthymol for every 100 grams of ointment. Grams of ointment cancel, and you can see if you multiply that across, 200 grams times 10% gives you 20 grams of just ichthymol. Okay? I won't belabor that process, but let's do the same thing for the 5%. There we started with 450 grams. So 450 times the 5% gives you 22.5 grams of just ichthymol. And hopefully it makes sense that if we had 1,000 grams of petrolatum, petrolatum doesn't have any ichthymol in it, so its percent essentially is 0%. So 1,000 grams times 0% is 0 grams. There's no grams of ichthymol from the petrolatum. So in the end, if you just add everything up, so this plus this, and since there's nothing there, but in the end you add it all up, you get 42.5 grams of just ichthymol. All right? Step two was to find the total weight of the active ingredient, ichthymol. Step three is simply to take the total weight of the ichthymol divided by the total weight of the product and divide those out and then times 100 to express it as a percent. So total weight of ichthymol divided by the total weight of the product divided times 100% gives you 42.5 grams divided by 1,650 grams times 100 means our final total concentration of ichthymol is 2.58%. Okay? Two things. Is that the way you probably would have done it anyways, even if you had no idea what the hell a alligation medial was? That's probably the way many of you would have approached it, is to figure out how much drug is in each ingredient, add it all up, divide by the total. That's kind of all it is. The second thing I would tell you, this was an easy example, because I told you the weights of each of your ingredients, and all you had to do was figure out the final percent. These next questions we're going to do are more difficult because I give you the final percent, and you have to work backwards to find the relative amounts of the ingredients. So where we're getting to is more difficult than where we started at, but hopefully that makes sense. And that did illustrate to you the process, the three steps for the alligation medial. Total weight of the product, total weight of the drug, take the drug divided by the product. That's the three steps, not overly difficult. Okay? Now, this is where it gets to be important here. Alligation alternative. We're going to do the first part. There are two main parts to an alligation alternative. We are going to focus on these next two questions on just the first part, which is determining the proportions. Remember I said an alligation alligation alternative is all about proportions. So this is really important. This is the biggest step to this, is setting up all of these proportions. So the question says, in what proportion should zinc oxide ointments of 5% and 20% strengths be mixed to make a 15%? Okay? And in all of these calculations, when do you know to use an alligation alternative? It's the formula, it's the way you process it when you have a high concentration and a low concentration, and you want something in the middle. So you mix a high strength and a low strength, and you get something in the middle. And I think I skipped, for the sake of time, the slide that said, if you take a 2% and mix it with a 10%, do you get a 12%? No. That's kind of where the intuition fails you. When you mix those two, you are diluting the 10% down towards 2%. You're also fortifying the 2% towards 10%, but you get something in the middle. And with these alligation, when you do a high strength and a low strength, the only answer you can get is something in the middle. But where in the middle depends on how much of the high versus how much of the low, and that's what these calculations are going to do. But in the end, we always are going to start with a high strength and then a low strength and solve for something in the middle. So this is the way to set these up. So again, if you're practicing now and writing this down, this is the whole trick, is being able to write this out. Start on the left-hand side of your page and put the high strength on top. So what is the highest strength that we have? We're using a 20%. That's the highest strength we're using. Okay? Write that on the left, up top. Then below that, directly below, but down a ways, put the low strength. We are mixing our 20% with our 5%. The low strength we're using is 5%. So do you see where I've lined those up, but I've put some space between the top 20 and the 5 below? There's some space down below. And the reason is, what you're now going to do is to the right and in the middle, between the 20 and the 5, directly in the middle, but to the right, write the target percent. What are we trying to make? We are trying to mix our 20 and our 5 to make a 15%. Okay? You have something that looks like that. This is important. It's a visual method. It's a great method, but it does take this kind of little bit of artwork to set up, all right? So now what are you going to do? We want to draw a triangle, if you will. Draw diagonal arrows. What you need to do is have an arrow going down from the 20, from the top left to the lower right. You're drawing an arrow going that direction. And from the bottom left up to the top right, you're drawing an arrow going up like that. That's supposed to make something that I say kind of looks like a triangle. You agree? Again, my poor art skills there. But you're basically trying to make a little bit of a triangle there. So far, so good? Let me get rid of my markings because I'm not sure that's helpful. Oh, come on. Never erases right away. All right. So far, so good. Now, here's the deal. Follow the arrows in both directions and cross-subtract. It doesn't matter which one's higher or lower. You take the higher number and subtract the lower number. Okay, so we have 20% angling down towards 15. What is 20 minus 15? 5. So what you're going to do is follow that arrow down and put a 5. Okay? Remember this, do not carry the units. It is no longer a percent. There are no units after you cross-subtract. I'll explain why here in a minute. But just take your two numbers that are in the same units and then subtract and write the number down, though diagonally. But keep in mind, I wrote this in about the same level, you'll notice here in a little bit, as that 5%. Okay? Now let's do the same thing. Going in the other direction, following the diagonal up from the 5%, let's take 15 minus 5. Okay, what is 15 minus 5? 10, and write that so that it's pretty much at the same level of the 20. Okay? So, high strength over low strength. Target in the middle. Cross, diagonally subtract. Write the number, follow the arrows down from the subtraction, finding with the diagonal. Same thing from the lower, go diagonally up, cross subtract, put that number up on top. No units on the subtracted values. All right? Why? What have we just done? The number we have, you don't have to write this down, but as far as the units are really parts. It doesn't have a unit. You've converted from a percent to saying parts. And parts aren't grams, they're not milligrams, they're not mils, they're just a relationship. That's what this is where a little bit tricky. The number we have says we need 10 parts of our mixture to be the 20%. Do you see where this line goes across? So what I want you to do is circle this, and connect them because they go together. The 10 parts represent the 20% ingredient, whereas down below, the 5 parts that we got down here represent the 5%. That's why the arrows are going across. All right, I wish I would have better art skills. All right, so making sure I use my color coding. Those are connected together, all right? Do you see where those numbers came from? I have 10 parts out of 10 parts for the 20% and 5 parts of the 5%. A part is a relationship to each other, okay? So I need 10 parts of the 20%. How many more parts is that than the 5%? It's 5 additional parts. Would you agree? I need twice as much. Just looking at those numbers, if the relationship, if I need 10 of the 20 and 5 of the 5, then I need twice as many of the 20 as I have of the 5. It's just a number that you can use to compare one to the other. And you're going to see that here in a minute. All right. The last thing is okay, let's go back to the next step. The last step in terms of these proportions is you need to know 10 parts out of how many total. What are the total parts? If you have 10 parts from the 20, and 5 parts from the 5%, what's the total number? Just add them up. So it's 5 plus 10, would you agree? So when you add up the total number of parts and get 15 parts, what you need to do is divide, this is important, the total number of parts, oh, I was going to do it this way. Use a different color. The total number of parts goes in the denominator, and it's the same number that goes in the denominator of each fraction. So in the end, I have 10 over 15 is my proportion for the 20%, and the 5 over 15 is the proportion for the 5%. That's an important proportion. Remember, this is about proportions. I can now make any amount of ointment be 15% as long as I use 10 out of 15 parts as the 20% and 5 out of 15 parts to be the 5%. Okay, and we will put these into action here in a minute, but it's important that you understand the relationship. Okay, so that okay so far to visually how to get where those numbers came from. Okay, does that work? We're saying that if you use 10 parts out of 15 the 20% and 5 parts out of 15 to be the 5%, then you mix those together, you get a total. What is the final percentage? When you mix those in that ratio, what percent concentration do you get? 15. That was the whole point to that. All right, so let me see if I can prove that to you. Let's prove that it works using both the alligation medial that we started with as well as the algebraic method we did last time. So let's start with this. If I want to confirm that, what we just said, step 1 for the alligation medial was the total weight. What is the total amount, I should say, not weight, total amount. While we don't have an actual units, we have parts. So would you agree, what we just calculated is that we needed 10 parts of the 20%. And 5 parts of the 5%. So what is 10 parts plus 5 parts? That's 15 parts. So our total amount for step 1, our total amount will be 15 parts. All right? Step 2, and this is where I may lose some of you, is to take certainly the amount of the actual ingredient. But I have to be vague here because I don't have it in actual weight. I know my percents. Would you agree? This is the percent that I'm using for the high strength. This is the percent I'm using for the low strength. The amounts I have for all of those, I know. I'm going to be using 10 parts of 20% and 5 parts of 5%. So just multiply those. The trick is here is parts and percent don't cancel. All right? So if you're going to multiply them together, they just combine. So what is 10 times 20? Are you okay with that? 10 times 20 is how much? 200. And what is parts times percent? Parts percent. Just keep them together. We have parts percent as the units. But are you okay where the 200 came from? I just multiplied the numbers together. I then just combine my units, parts percent. Same thing for the 5%. I have 5 parts of that, and I have it 5%. 5 times 5 is 25 parts percent. I just multiplied them together. Then to get the total zinc oxide, all you have to do is add them up. Now these have the same units, so 200 parts percent plus 25 parts percent is how much? 225 parts percent. All right? That's how you would express the total amount of zinc oxide in your formulation. The last step was to take the amount in your formulation, so remember the total amount of drug, which we said was this, divided by the total amount of the product down here, okay, and just divide it out. Here's what's kind of cool though. Do you see that your parts units cancel? You have parts on the numerator, you have parts in the denominator. The units of parts cancel each other. So all you have to do is take the number 225 divided by 15. What is that? Do that on your calculator. 225 divided by 15 is 15. And you'll see that the last remaining unit is percent. So we've just proven that mixing 10 parts of 20% with 5 parts of 5% gives you 15% final concentration. But you don't look like you believe me. Some of you don't even look awake. So let's see if this wakes you up. Algebra. Let's do it the same way we did last time. Because remember, what we did last lecture was mass 1 plus mass 2 equals mass 3. So let's express all of these things in terms of the mass. Because here's what we're doing. Let's start over here with C1. C1 essentially is the fact that we're using a 20% ointment for its concentration. Its quantity, bear with me, is 10 parts. Okay, so 10 parts for the quantity. So its mass is 20% times 10 parts. The thing we're adding to it is the 5% ointment, so its concentration is 5%, and it has 5 parts, so mass 2 is 5% times 5 parts. And lastly, when we mix those two, what do we get in the end? Or what is our mass 3? It's the concentration we get at the end, which we don't know, so we're going to say X% here, because this is what we're solving for. But we do know, and this is important, bear with me, make sure you understand this. Our quantity 3 is going to be the sum of quantity 1 plus quantity 2. If you add two things together, the final quantity is the sum of those two things. So 5 parts plus 10 parts is 15 parts. Therefore, mass 3 is X times 15. So now all we need to do is to solve. Let's pull mass 1 down here. We'll pull mass 2 down here. Oh, it didn't change. And we finally have mass 3 down here. So if you do that multiplication, our units are the same. 20 times 10 is 200. 5 times 5 is 25. And X times 15 is 15X. 225 equals 15X. Divide by 15, and you get 15%. So did I finally convince you that the alligation alternative method works? All right, so that's the idea behind all of this. Now, let's use the alligation alternative method, because I think you're going to see it's pretty quick. Now, let's see if you remember. Where do we start? What's the first number I write down? I should read the question. In the proportion, what is the proportion of 30% and 1.5% hydrogen peroxide when you want to make a 3%? So I have a high strength, 30%. I have a low strength, 1.5%. And what do I want? Something in the middle, right? I want 3%. So what's the first number I write down? Is the high strength. And I write it on the left, up high, so there's my 30. The next number is the low strength. I write the low strength directly below the high strength, but down a ways. Give yourself some space. So that in the middle, to the right, you can write the target percent. What I want to make is 3%. All right? So far, okay? What do? We do our diagonals, diagonal arrows. So we'll draw those in. So a diagonal from 30 down to the 3, and a diagonal arrow from the 1.5 up to the 3. Okay? Now, you can go in any order you wanted, but let's keep those diagonals going and cross-subtract. So going from the top, what is 30 minus 3? That would be 27. No units because we're in parts. What is 3 minus 1.5? 1.5. Are you okay with where those numbers come from? Now, this is where I hope I didn't lose you before. You divide those numbers. So both of those numbers, both the 1.5 and the 27, underline both those numbers because you need a denominator. Those numbers that you've cross-subtracted represent the numerator of a fraction. What's the denominator? It's the sum of the two. Add up the total parts. So if I take my 1.5 plus my 27, the total of that is 28.5. That's the denominator for both of those fractions. So the proportion I need is that for the 30%, and this is where I want to emphasize, do this if you're taking notes, circle the percent here, draw a line and connect it to its proportion. Same thing down here, circle that one, connect it over to its proportion, because we're going to start to use that here in a minute. All right? So the proportion I need is 1.5 out of 28.5 to be the 30%, and I need 27 out of 28.5 parts to be the 1.5%. So that, okay with that? That's all you got to do. And I need, as we go forward now and a little bit faster on setting this up and coming up to those proportions, just set them up correctly, cross, subtract diagonally, divide by the sum of the two answers. Okay, that's all I would say here is those. And again, you guys are going to use your calculator, so you can just leave those numbers. Fine, don't have to change them. But that's kind of an ugly number, right? 1.5 over 28.5. Could you make it a little bit nicer if you multiplied both the top and the bottom by 2? You could call it 3 out of 57 instead of 1.5 out of 27, or 28.5. You could also divide the top and the bottom by 1.5 and convert it to 1, essentially, over 19, and the bottom you could convert that to 18 out of 19. So you can reduce those numbers. I'm already losing some of you. Just realize these numbers here, you've got to keep the same proportions, but you can make them cleaner. But don't. you'll mess it up, some of you. So let's just leave it at that, all right? New question. It says, how many, and we're going to go further this time. Remember I said there were two parts. The first part was this whole little setting up and coming up with the proportions. That was part one. We still have another part, all right? We're going to go further. How many grams of a 50% weight per weight zinc oxide ointment should be added to 3,200 grams of a 5% weight per weight zinc oxide ointment in order to prepare an ointment that contains 20% weight per weight? Okay? We have a high strength 50% and a low strength 5%, and we want to make something in the middle. We want to make 20%. All right? So, does that sound familiar? So I'll try to describe it here. You can write it out. I put my 50 on top. I'll put my 5 down below. The 20% is the target. It's in the middle. All right? So I cross subtract, going from 50 down to 20. That's subtracting. It gives me 30, so I wrote the 30 across from the 5. I cross subtracted going up from the 5% to the 20. The difference between 20 minus 5 is 15. Following that diagonally up, I wrote the 15 across from the 50%. I then added those two answers together. My 15 parts plus my 30 parts means I have a total of 45 parts. Therefore, I divided each of my values by 45. In the end, what I'm saying is that of the 50%, I need to have 15 out of 45, okay? And for the 5%, I need to have 30 out of 45. So I'm going to connect those together, all right? So far, so good? So now is where we need to start thinking, though, about what is in the numerator and what's in the denominator. So on the 50%, I said I have 15 out of 45. It means 15 parts of the 50% out of, and this is why what I want you really to do here is circle the bottom, circle that denominator, and draw those lines to there. Because the 20%, which is the total in the end, is the 45 parts. The 15 parts represents the 50%, and the 5% represents the 30 parts. All right? Because now, how do we go about approaching this? What do I know is this. What I know here is that I have 3,200 grams of which strength? The 5%. So if I have that amount of weight of that ingredient, and that ingredient represents the 30 parts, then what I can do is set my 30 over 45 equal to the fact that I have 3,200 grams of the 5%. Remember, the 30 parts represents the parts of the 5%. The question told me I had 3,200 grams of 5%. So I'm going to use this proportion. So I'm going to say 30 over 45 is equal to having 3,200 grams of just the 5% over x. And when we solve for x, x will represent the what? The total, the 45 value. And we said the 45 represents the 20%. It's the total amount that we make. So solve for that. What is essentially 3,200 times 45 divided by 30? If you do that math, if you solve for x, you find that x equals 4,800 grams. All right? What does that 4,800 equal? That 4,800 equals the 45 parts. Okay? That represents, so 4,800 grams represents the 45 parts. All right? But what are we trying to find? We're trying to find this. In the end, what we're still trying to find is this value. So we're not done yet. Here's what you can do. Well, if this value, if the 4,800 equals that 45, then it also equals that 45. Okay? It's the same total. It's the same amount. The 45 parts represents the same amount. So now I can set up a second proportion where I set it equal to X amount of the 50%, because remember the 15 parts represents the amount of the 50%, over the total weight, which we just solved now. Now we know what the total weight. We know what the 45 parts represents. We know it represents 4,800 grams. Solve for X by doing 15 times 4,800, divide by 45, and you get that X equals 1,600 grams. And since that is the top of, represents the 15 parts, it represents the weight of the 50% zinc oxide. Okay? Now, can some of you get to that answer a little bit faster? Let's just talk about some relationships. I'm doing it this way so that if you know the proportions, you can answer all of these questions. Just ask yourself, what does this represent? This weight represents which one of those fractions, what part of that fraction, okay? This part, so I guess the two things, and again, you can solve these however you want. I'm still going to do it my way to try to be consistent in showing you this. Would you agree that once you know the amount of the 5%, and once you know the total, the difference between those has to be the amount of the what? The 50%. So what is 4,800 minus 3,200? 1,600, okay? So you can just subtract that. It works. It's fine. Okay, I'm showing you another way of doing it, but if it makes sense to you to kind of finish these questions up a different way, so be it. Now, I set up the ratio of 15 over to 45 and 30 over 45. Could you also have done this as setting up 15 over 30? What does the 30 represent? 30 parts represents the weight of the what? The 5%. Did I already know what that was? How much 5% did I use? Remember, I knew that was 32, I just put my hand on here, 3,200 grams, right? Did I know? What does the 15 represent? The 15 represents the 50%. I did not know what that was. So if I set that up as X, you could have solved it that way as well. But do you see, this is what's important. You have to set up these ratios first. You have to set up the proportions. Once you have the proportions and know what the numerator means and the denominator for each proportion, then you can solve all of these questions. So again, let's just keep practicing. Okay, my hard work doesn't help. Next question. It says, you need to prepare 250 mils of a solution containing 40% weight per volume of dextrose. You want to prepare that. What are you going to use to prepare it? I'm going to use a high strength 50% and a low strength 20%. So again, 50% and 20% mixed together such that in the end I get exactly 40% concentration and 250 mils total. All right, so now we're going to add that volume in there. So let's set this up the same. High strength is 50% over the 20%. To the right and in the middle is my target, which is 40%. Let's start at the 50%, go down diagonally crosswise. 50 minus 40 is equal to 10. That 10 is written directly across from the 20%. Let's go diagonally up from 20%. Going up, what is 40 minus 20 is 20, so I write that 20 directly across from the 50. Okay? So this is what's important. I'm going to circle the numerator and circle the 50%. Those two are what's tied together. Okay? In the denominator, for the 20%, that represents the 10 parts. All right? Now, what does the denominator, the 30, represent? The 30 represents the 40%. So it's the same value both here and here. Oh, let me circle that. That's key. If you got that, if you understand what the parts, the numerator of which fraction goes to which value, then this next part gets to be really easy. All right? So my question to you now is, what does the 250 represent? Because that's the only other number I need to be able to solve this. It says you need to prepare 250 mils of a solution that contains 40%. So isn't that the volume of the final product? Okay, the total amount. And that total amount basically is equal to the 30 units. So that's the same as this, which is the same as this down here. So all I have to do is set those proportions equal to some unknown amount in the top. If we just focus on this part up on here, what I'll do is say, I don't know how much 20% to use, or 50% to use, I'm sorry, but I know what the total volume is going to be. My 30 parts represents 250 mils. And I can do the same thing on the bottom. Again, now X on top represents the amount of the 20%, because the 10 parts, I don't know how much that is, but that's the amount of the 20% I need. But I know it's still over a total of 30 parts, and I know 30 parts is going to be a total of 250 mils. So now I can solve. So is everyone okay why this number is the same as this number? Okay? Because they all represent the total of the 40%, and the 40% is the total volume that we're using. Okay? So now if you solve for those, you basically just solve for X, and for the 50%, solving for X, you would get 167 milliliters. And on the bottom, for the 20%, you solve for the X for the 20%, and you get 83. Does it make sense that if you added those two volumes up, what is 167 plus 83? 250. That's what you were trying to do, was to make a total of 250 mils in the right proportion so that when those concentrations are mixed, you get a total of 40%. Okay? Well, I like this because it is the same thing but different. It is the same setup in terms of the proportions. But the question we're going to answer is different. So let's see if you can figure out how to answer a different question with the same proportions. Because the question says, you have already made 250 mils of a solution containing 50% dextrose, and you need to modify it. You want to prepare a solution that, again, contains 40%, and you still have a 20% solution to mix to make that. But now what I want to know is how much of the 20% solution would I need to use to dilute my 250 mils of 50% down to a 40% solution. Okay? So, and again, I'll need to know what the final volume is after the dilution. So let's look at the ingredients. It's the same. Look at this proportion setup. It should be the same way before because I have a 50% and I have a 20%. I have a high and a low, 50 and a 20, and what I still want to make is in the middle at 40%. So if you cross-subtract and do all of those same fractions, they're exactly the same. So is everyone okay that this is exactly the same as what we just did? I need 20 parts to be 50. I need 10 parts to be 20. Okay? Now, we've got to be a little bit careful. Because what does this 250 milliliters represent? Okay? It's not the total amount. It says 250 mils of which? Of the 50% dextrose. So I would argue that this volume now represents that amount. The 250 mils is the volume of the 50%, and we said of the 50%, I need to have 20 parts. So now what I can do is set that equal to, essentially, set that value over to here. The 250 represents the value of the 20 parts over X. Now when I solve for X, I'm solving for the total. I know how much 50%, 250 mils. If I solve for X, I see that what I need is, in the end, to make sure that 50%, that 250 mils of 50% resides in a total volume of 375. Okay? And this 375 represents that value, which represents this value, which is the same as this value. Do you see that? Remember, we just solved for the total. And that total, the 375 mils, represents 30 parts. That 30 parts on top is the same as the 30 parts down on the bottom, so now I can set up a proportion where I have my X unknown amount of 20% on top, the 10 parts, over what I now know of 30 parts, which is 375 mils. So now when I solve for X, I get 125. Okay? Could you have intuited that differently? Could you also say, well, if I've got 375 total and 250 is the 50%, just subtract those? What's 375 minus 250? It's 125. So you hopefully can see these connections. I'm trying to set it up so that you can, the key to these questions is being able to come up with those proportions and putting the right value across from the right proportion, whether it's the numerator or the denominator, whether it's an ingredient or the total, making sure that you can put up the numbers in the right spot. Okay. Last kind of main question, and we're going to try to answer it the same question three ways. So it says, how many grams of zinc oxide powder, 100% pure zinc oxide, how many grams of zinc oxide powder should be added to 3,200 grams of a 5% ointment in order to prepare a 20% ointment? Okay? So the only little trick to this is what percentage would you assign to a pure drug powder? Its percentage is 100%. So that's why on top I have 100%. That represents the strength of the pure zinc oxide powder. Put that over the 5%, which represents the low strength that we are adding it to. And in the middle on the right is my target percent, which was 20. So is everyone okay with the 100 over the 5 and then the 20 on the side? That's the same process. Cross-subtract the same way we've done all of these. 100 minus 20 going diagonally down is 80. Then going up from the bottom left to the upper right, 20 minus 5 is 15. Okay? 15 plus 80 is 95. So my total is 95. So again, of the 100%, I need 15 parts. Okay? Of the 5%, I need 80 parts. All right? And lastly, my 20% will represent the 95 parts. All right? Now, what do we know? We know this, okay? We know 5%. We know we have 3,200 grams of 5%. So where does that number go? that number goes down here, right? Because we know the 5% represents the 80 parts. So again, if I just carry that over here, then I can say that that equals 3,200 grams over X. And now when I solve for X, I'm solving for the value, the weight that represents the 95. So essentially, I need to make a total weight of 3,800 grams. This 3,800 grams now, represents the total of the 95, which is the same as that 95 up there. So let's set up another proportion that says some unknown X amount of the 100% powder over a total weight of 3,800 grams. Now when I solve my X represents the weight of the pure powder, the weight of the zinc oxide powder, the numerator, the 15 parts. When I solve for that X, I get 600 grams. All right? Could you have intuited that? What is 3,800 total minus 3,200 for the 5%? 600 grams. Yes, it does work, but okay. Now, bear with me here. Let's do this with the alligation medial method, because you do need to be able to kind of understand the alligation medial method. Using what we just solved, though, step one was the total weight. The total weight of everything, we just said, using the alligation alternative, was 15 parts of the 100% and 80 parts of the 5%. So what is 15 plus 80? 95. Step one, the total weight of everything is going to be 95 parts. Step two was just the parts or the amount of the zinc oxide. So we have to take our weight of the zinc oxide times the percent of the zinc oxide. So for the pure powder, we said 15 parts. 15 parts times its strength of 100% gives you, 15 times 100, gives you 1,500 parts percent. Just combine the units. Then we said 80 parts of the 5%. So what is 80 times 5? That's 400. That's the number. And just combine the units, parts percent. They have the same units. We can add them up. The total amount of zinc oxide is the 1,500 plus the 400. So it's 1,900, and the units are still parts percent. Last step, essentially, is, again, I will tell you to take the weight of the drug, in this case, the zinc oxide, divided by the total weight of the product here. And remember, parts will cancel. So 1,900 divided by 95, with the only remaining number being, or unit being percent, is 20. Do that math, and it comes out to be 20%. We've just proven that that proportion of 15 parts of 100% and 80 parts of 5%, when mixed together, gives you a total concentration of 20%. And I know what you're saying is that I only got 2 minutes, so I'll get it done. I love algebra. I love what we did last class. So let's do algebra. Does it still work? And in the end, you're seeing that, yes, you can answer a lot of these questions more than one way. I will warn you on the test, I may tell you to answer it a specific way. I may tell you to have to show work in one way or the other. So it's not like, oh, I'll just do algebra and ignore the alligation thing. That's not right. You're going to have to do all of these. Plus, alligation is awesome too. So anyway, let's finish up with the algebra. Could you have done it this way? We took zinc oxide powder. We said that's 100%. So the concentration of the powder is 100%. The amount of zinc oxide to use, we didn't know. So X. So my C1 was 100%. My Q1 was X. So my mass 1 is what? 100% times X. What did we add that to? We added that to an ointment that had a concentration of 5%. So C2 was 5%. Q2, we were told was 3,200 grams. We were told that. So I know I have 3,200 grams Q2 of a 5% ointment. That's C2. All right? So going back to mass 2, take your 5% times the 3,200. C3, what was our target? What did we want this combination to have a concentration of? 20%. So my C3 is 20%. Now bear with me if you tune me out. Make sure you understand this. This is still where people mess up. How do you come up with your Q3? Remember, Q3 is simply the sum of Q1 plus Q2. So we didn't know what Q1 was, but it was X. So Q3 is 3,200 plus X. Okay, it's two parts to it, but this is essentially Q3. That's why mass 3 will be 20%, that is the concentration, the C, times the Q, which is 3,200 plus X. Don't forget that. Now let's just do some of the algebra. Again, here's my mass 1 over here. Here's my mass 2 over to there. Those are what we're going to add up, and in the end, that's going to equal mass number 3. All right? So if you do that math, 100 times X gives you 100X. 5 times 3,200 is 16,000. Set that equal to. Now remember here to cross multiply the 20% times both of these values. So that's why it equals 20 times 3,200, which is 64,000, plus 20 times x, which is 20x. So do a little bit of algebra, subtract 20x on both sides, and you get 80x on the left. Subtract 16,000 from 64,000, and you get 4,800. So divide each side by 80, and x equals 600. Okay? So we have gotten 600 grams now in each of the 3 different methods to be able to do that. All right? So we'll end with that. We'll keep, again, the next class we'll go a little further. We're going to keep practicing with this alligation alternative, but how many ingredients have we been mixing in all of these questions? 2. What happens when you add 3? Be ready for the next class, all right? So we'll expand on our same alligation thing, but we'll add to 3 ingredients, and we'll do review.